This is 2.6 in college algebra, and the name of this section is Solving Linear Inequalities, and it's on page 239. Shouldn't be too difficult and should go pretty fast and easy, so let's get started. Middle of the page, see a box underneath the purple, and it says when both sides of an inequality are multiplied by a negative number, we must reverse the inequality sign. So that's just a reminder from junior high to switch the sign, flip it around when you multiply by a negative number. So let's go ahead and get started with an example. So real fast and easy, 3x minus 5 is less than 6 minus 2x. You solve this as if this were an equal sign. So we add the 2x, we move the negative 5 over, and we divide by 5, and we're done. Okay. When you do B on example 1, 13 minus 7x is greater than or equal to 10x minus 4, you do the same thing. And let's just look at that one real quick. If you look on page 240, look at the example there, because just want to remind you about the answer is x is less than or equal to 1. And just remember there's set builder notation, x such that x is less than or equal to 1. Or if you want to use interval notation, negative infinity to 1 inclusive. Okay, so that's just the two ways to label your answer there. Or I guess three ways to label your answer there, depending on what they're asking for. But anyway, just be familiar with all three of those ways of labeling that answer. This next section is on compound inequalities. And what that means is when we have two inequalities and we join them together with the word and or the word or, they're called compound. So when you have and, it's called a conjunction, just like in English. And when you have or, it's called a disjunction. Okay, and there are a couple different ways to handle these. And what we're going to do is look at the conjunction first. So if we have negative 3 is less than 2x plus 5 and 2x plus 5 is less than or equal to 7, we have what's called a conjunction. And one of the ways you know that it's a conjunction is, oops, I forgot the 5 here. So let's put that 2x plus 5 is less than or equal to 7. Okay, we can tell it's a conjunction because the first part of that and the last part of that are the same. So it means that 2x plus 5 is somewhere between negative 3 and 7. So it's in there somewhere because it's bigger than negative 3, yet it's less than or equal to 7. So what we can do is we can do a shortcut. Whenever you have the word and, there's a shortcut available. And that shortcut means that we just write the 2x plus 5 one time. We don't have to write the and 2x plus 5 is less than or equal to 7. We write that. And that tells you that it's in between. And then we use algebra to solve this. So we're trying to isolate the 5 or the x, so we have to get rid of the 5. So what we do is we subtract the 5 from all three of those places, the left and right of the inequality and the in between. So that gives me negative 8 is less than 2x, which is less than or equal to 2. Okay, and then we divide by 2, and we solve for x, and we get our x. So negative 4 is less than x, which is less than or equal to 1. So we know that our x, our number for x, falls between 1 and negative 4. So that being the case, when we do this on the number line, we can put -4 here, we can put 1 here, and we can show that it includes 1 and does not include -4, and it's all the points in between there. If we're going to do it in set notation, we're going to get x such that x is, well, let's do it this way. Let's get rid of this x. X such that, basically we're just going to use this. -4 is less than x, which is less than or equal to 1. Okay, so that's set builder notation, and then we go to interval notation, -4 and 1. That tells me that my x is between there. Okay, so let's look at a disjunction here for a minute. Hi, Scott. No, you're fine. I just hit pause. Oh, no, you're not bothering me at all. So absolute value with inequalities, page number 242 as we continue section 2.6. This is where it can get a little tricky, but I think we'll be okay. One of the things you need to know is that x is less than 3. If we were to make a number line, and I were to put 0 here, -5, +5. This says, if you remember, the distance x is away from 0 is smaller than 3. So that means that x is going to be a number somewhere between 0 and 3, because it says x is a number no more than 3 away from 0. But it also means that it's no more than 3 away from negative. Okay, so it also goes in this direction. So my 3, oops, wrong button. My distance from 0 can either be 3 this way or 3 this way. Okay, so what does that tell me about my x? My x is going to be somewhere in here, so I could write it as -3 is less than x, which is less than +3. So my x is somewhere in between there. And that's what this absolute value does, is it tells you that basically I have a, in this one, I have a conjunction because it's somewhere in between these two, and I can write it with a shortcut method. I don't have to use the word or. Okay? So if I have something like the absolute value of x is greater than or equal to 1, I've just turned that into a disjunction, because what that means, on a number line again, is my x value has to be greater than 1. So it has to either start here and go this way and include all those numbers, and it can also be equal to 1, right? Or it's going to start at -1 and go this way. It's going to be one or the other. Okay, so if the absolute value of x is greater than or equal to 1, it has to be a number further from 0 than 1. Which brings us to some that are a little bit more equation oriented. So if I have something like 2x plus 3 is less than or equal to 4, that is going to give me, because it's the less than or equal to sign, negative 4 less than or equal to 2x plus 3, which is less than or equal to 4. So notice what happened here. I took this, I wrote it as a negative on the left, a positive on the right, and I put this in between. And that's when it's a less than or equal to sign. Okay? When this is a greater than or equal to sign, it needs to be a disjunction, so it's going to be or. So if we had, let me write that again, an absolute value of x is greater than or equal to 1, we're going to get x is less than or equal to negative 1, or x is greater than or equal to positive 1. So notice two things happen. I have an or here, and I also have a sign like that and a sign like that. Two different directions on my sign. So if this sign is a greater than or equal to sign, I've got a disjunction that's going to look like that. The less than or equal to sign, I've got a conjunction that is going to look similar to that. So let's try example 4 in the middle of page 242. So I have 3x plus 5 is less than 5. I'm sorry, 3x plus 2. So because we have a less than 5, I've got a conjunction. So I know I'm going to have a negative 5 is less than 3x plus 2. Notice the M off. Is less than 5. Subtract 2, subtract 2, subtract 2. Negative 7 is less than 3x, which is less than 3. Divide everything by 3. Negative 7 over thirds is less than x, which is less than 1. So my solution set then, again, in set builder notation, x such that negative 7 thirds, notice I'm just rewriting the inequality, or negative 7 thirds, not including, and 1, not including. And then you can draw the graph then, just showing that the information we're interested in is somewhere between negative 7 thirds and 1. So this next one, we have a disjunction. So we're going to write it as two separate inequalities here. 5 minus 2x is less than, let's make that greater than or equal to, less than or equal to negative 1, and 5 minus 2x is greater than or equal to 1. So notice my sign switched from here and here, and that's a negative and that's a positive. Now I just go ahead and solve this. Negative 2x is less than or equal to negative 6. And I'm going to divide by a negative. Remember, when we divide by negatives, the sign changes. Oops. I divided by a negative, I get a positive 3. And over here on the right, I get negative 2x is greater than or equal to 4. X is, again, sign changes because I divided by negative, and I get that. So when I graph this on a number line, I get greater than or equal to 3, and then everything that way. And I get less than or equal to 2, and I go that way. So notice they're disjointed. There's a disjunction. There's nothing in common. So set builder notation looks like this. x such that x is less than or equal to 2 and x is greater than or equal to 3. And again, interval notation is going to have a union sign, and we're going to have starting at negative infinity and going to 2, and then going from 3 to positive infinity. All right, so that's those inequality problems. Okay, so let's just look a minute on page 243 in application problem, example 5, just to see how these inequalities work. So, for her house painting job, Erica can be paid in one of two ways. She can be paid $250 plus $10 an hour. So she's handed $250 just for painting it, and then she gets $10 an hour. Or she can just get paid $20 per hour. Okay, so she has a choice there. And she's like, okay, let's see, which one am I going to do that's going to pay the most money? Well, it all depends on how long it takes her to paint the house. So let's say it takes n hours to paint the house. So if she is making $20 an hour and it takes like 6 hours, she makes 20 times 6 is 180. But if she's working n hours, it would be a total amount. So her total here would be $20 an hour times n, which is how many hours it would take her. For her first one, it would be $250 plus $10 per hour times however long it takes her to paint. So it'd be 250 plus 10n. Okay, so we're trying to figure out which one is going to pay her the most. Is the 250 plus 10n going to be the best deal, or is just 20 times n going to be the best deal? Well, one of the things you'll find out is it depends how many hours it takes her, because if it only takes her, say, 2 hours to paint the house, well, she's made $40 here, and up here she's made $20 plus $250. So there's a time where this equation is going to be the best choice, and there's a time where this is. So we need to figure out where is that point, how many hours before one is better than the other. So what we're going to do is we're going to find out when this is better than this. So here's the inequality we're going to write. So we're going to say, all right, so 20n is greater than or better than 250 plus 10n. So what we're looking at is that n value, that number of hours it's going to take. Where she gets paid this much, it's going to be better than when she gets paid this much. You could flip the sign around and say, when is this one going to be better than this? It's going to be the same thing, so it doesn't really matter. But when is 20n this going to be better than this? At what point? Okay. So all we have to do is go ahead and solve this. So let's see. We subtract 10n from both sides. And we get 10n is greater than 250, and n is greater than 25. So that tells me that when n is greater than 25, $20 an hour is the best deal here. So let's try that. So let's say she paints for 30 hours. 30 hours times $20 an hour, that gives her $600. That's if she were to use this plan right here. Let's use the top one. If she's making $10 an hour and she works 25 hours, that's $250 plus the initial 250 hours just for taking the job. So she makes $500 there. So for 30 hours, she makes $600 using this plan, and she makes $500 using this plan. So let's look at that from the other way now. if, for instance, she worked less than 25 hours. So let's say that she worked 20 hours. So that equals my n. Let's see if this top one is the better deal now, because according to our problem, it should be. So in the top one, we've got $250 plus $10 an hour times 20 is $200. So she'd make $450 if it took her 20 hours using the first plan. If she was doing 20 hours at $20 an hour, she'd make $400. So this plan right here for 20 hours is not the best plan. It becomes the best plan if it takes her over 25 hours. So that's the tipping point there. She has to look at the job and be like, yeah, it's going to take me 30 hours, so I'm going to take this plan right here. It's only going to take me 19 hours or 23 hours, then I'm going to take this plan right here because it's going to pay the best. So that's a story problem there, just to kind of let you see how to familiarize yourself with inequalities. So that's it for 2.6.